Hey guys, and welcome back to this Python 101 series. So in the last video we left off with our game board created using a 2D list, and that game board is being displayed using this piece of code here, these two for loops. We've used a printf statement to make it look a bit more pretty. We've provided user input and then casted it to an integer, and then finally we've also changed it here. And we've used the same piece of code as we did here to display the newly changed game board. So again, I think in the previous video I kind of alluded to what we will be looking at in this video, and specifically we're going to look at what are known as functions. So functions in Python, you may be wondering what a function is, but we've actually been using functions all along. They've just kind of been hidden for us. But if you go over to print and press Control and select onto it, we're then sent to this builtins.py file. Now these are a list of built-in functions that Python provides us automatically. And one of these functions is the print function. So we've got def, meaning define, I think, and then print, just the name. And these are a series of arguments that the print statement can accept. And one thing you may notice is before, if we just had a print statement, it would provide a new line for us automatically, and we needed to explicitly say that we don't want a new line. And we can actually see, if we go to the built-ins, we can see end followed by a backslash n, and backslash n is an escape character, meaning to add a new line. So this is the this isn't all of the this isn't all of the code for the print function, but it's kind of alluding to what's under the hood. It's kind of saying, okay, this isn't actually black magic, it's just other pieces of code that we're executing to allow us to do this sort of stuff. But you can imagine, let's say there's 20 or 30 lines of code. Let's say that, how many times do you think you're going to use a print statement? Most likely you're going to be using it quite a lot. Well, can you imagine writing the entire print statement out, 20, 30, 40 times when there's probably 100 or so lines of code, if not more? Well, then that's hundreds and hundreds of lines for just a few statements. And undoubtedly you're going to make a mistake. Even if it's something simple like our display code, there's only 4 lines of code here, but if we want to display our game board every time it's changed, or if we just want to display it at all in cases, then we'll have to copy and paste this code or write it out again, and undoubtedly again you're going to make a mistake. Your code base is going to be enormous for effectively something that isn't doing that much. So what we can do is wrap this into a function. Oops. So what I'm going to do is I'm going to delete this piece of code, and instead, actually, if you want, you can try to figure this out for yourself and write our display function for us. So use the built-ins file to help out. So as you can see, all of these functions have a def in front of them, followed by the name, so odd, or in this case pow for power, and then we've got some brackets, and then we've got a colon. Now don't worry about these arguments inside the brackets. We'll have a look at them, but for now you don't need to worry about them just yet. So pause the video and see if you can write a function to call our display code, so that we don't need to write our 4 lines of code out every single time we want to call the display. So assuming you've either done that or you're a little bit confused, what we're going to do is we are going to create the function. So I'm going to write def, and then let's say display, and we're going to say display game. Now just before that, I'm going to change this variable to row input, and we'll talk about why it's nice to do these sort of things in the next video. but for now just change these to row input and column input. So that's fine. And now we've got def, we've got define display game, and we've got our brackets and our colon. So next thing you want to do is press tab just once, and there you go. What we've done now is we have created a function. So if we press run now, you'll see that nothing happens, and if we enter our row and column, you'll see that nothing is actually presented to us, and that's because we're not calling it. So although we've written this piece of code, it's not executing. And to execute a function, you need to call it. And you do that by typing the name, so in this case displayed game, and the brackets. And then, what else? Oh, it's just a pep8 thing, fine. And then we press run, and we can see that it's now outputting stuff for us. And again, we need to put a display game down here so that we're outputting the changed result. 1, and there we go. So we've got the same output. You know, it's the exact same piece of code, but what's actually happening is instead of writing this code out multiple times, we're just calling this piece of code. So if you've got well, actually, what we can do is we can put what's called a breakpoint here. Just click inside this little header tab thing until you can see a red line. And then in PyCharm, you can press this debug. In VS and VS Code, you can just press run and it should work. But we've hit this place. This is where our Python code has stopped. Now, if we press step into using F7, we can see that we're actually going up to this piece of code here. And if we go all the way down and keep going, da-da-da-da-da. In fact, I'm just going to put another breakpoint here, press run, resume program. Oh, and then we'll have to, there we go, go back to debugger. And as you can see, we've gone to the displayed game thing again, step into, and we've gone back up to this display game function. So what's happening is this is, you can imagine, as a kind of container for our code, and we're calling this container, and it's executing the exact same piece of code. So what we could do, I mean, we could call this now 100 times, and we're probably not going to make a mistake now, because this, although we're calling it 100 times, it's just looping through this piece of code, which is what we want. So what we've now done is, although we've only got rid of 4 lines of code, we have actually got rid of some code, which is nice because we're now reusing this piece. You know, imagine if you've got a much bigger code base with, you know, 1,000 lines of code, 2,000, whatever, and you don't have functions. Imagine how much code is just being wasted, how much code we can reuse. You're probably going to find that half of the code there could be reused easily. So functions are really cool for that. So now we've created our little display game function. What I thought I'd do now is go out of this and create a brand new program. And what we're going to do in this program, we're going to use the existing interpreter, is we're going to build a simple calculator. That will do, and call it calc. Create. There's pipe, there it is. Put the main again. Main and hashtag, why not? Python and the script path, calc. There we go. So we're going to build a calculator. So what do we need for this? Well, we can obviously do things like num num1 is equal to 0, num2 is equal to 50, let's do something a bit more interesting, let's say 45, and num3 is equal to num1 plus num2, and print this out, num3, and run, and we can see that it's 95. But what this is actually doing is it's calling this piece of code, well, it's calling that piece of code, but it's probably also calling multiple other things inside Python. So this is really just calling a function. That's all it's doing. So although, you know, in Python, in programming, you shouldn't really reinvent the wheel, I think for this purpose, I think is absolutely fine, and we can do. Especially as there may be situations where, you know, Python may offer you a built-in function, but you need to change aspects of it. And there's complex ways of doing that, but also there's a simple way which is just recreating the method. Do I recommend it for beginners for just recreating the code? You can do. But do I recommend it in general? No, you'll want to do some other stuff, but that's beyond the scope of this for now. So, what we're going to do is we're going to create a add function. So def add, and we're going to add two numbers together. But let's say, let's say we've got a user input. Let's say we've got the user to add, or at least rather, we're asking the user to give us two numbers to add together. So we could do this by saying num1 is equal to, remember we need to cast it to an integer, input num1, num2, and number2. Cool. What's wrong with that? Oh, right, that's fine. So let's say we want to add these two numbers together using our add function. So how do you think we're actually going to do this? Because what we need is this piece of information, this variable, to go inside our add function, add it together, and then it gives us the result back. So what effectively we want is something like num1 plus num2. Which is pretty much what we had before. Well, there's another thing in Python, and all other programming languages I should add, which is passing in arguments. And you saw that briefly when we looked at the print statement. These are all arguments. So what we can do is we can actually say, okay, we've got an add method and we want to pass in some information, and we can pass in num1 and num2. So now if we say print num1 and num2, I think that's okay. And then we say, we call our add method and we pass in our number1 and our number2. If we run this, so we say number1 is 55, number2 is 48, we can see that it's gone into this add function and it's printing out exactly what we wrote, which was 55 and 48. And just to prove it, we can use a breakpoint again, put it next to our add function, or the place where we're calling our add function. That was the wrong button. Debug. We need to add, put in a number, 88 in this case now, and 45. We've now gone to add here. In number1, if we hover over it, it should tell us. There we go, hover over it, it's 88, it also says here, and num2 is 45. So these are the two pieces of data that are stored in our variables. We then press step into, which goes up to our add function, and it's passed in num1 and num2, which is 88 and 45, and we're then printing those two variables. And just another thing that we could do is, actually what's this saying? Yeah, so this is saying Shadow's name num1 from outer scope. This just means that these have the same name, and that, yeah, they just have the same name. There can be problems with things like mutability, i.e. you're doing something and changing it in another place, but we'll get onto that in a future video, probably the next video actually. So yeah, now actually yeah, let's change it to number1, number 2, run again, and it should be happy now. There we go, 12 and 12 in this case, and now we're outputting those. What's that saying? Reformatting file. Okay, cool. Okay, PyCharm's now happy with us, which is nice. So we've created our add function. So, well, we're printing out those two numbers, but why can't we just do number 3 is equal to num1 plus, oops, num1 number 1 plus number 2. We can do that, but what happens if we've got a result down here? You know, what happens if we want to use this piece of information? You know, maybe you're creating a game or something, or a robot, and you've got a function up here which is calculating something. Let's say it's calculating, I don't know, a kinematics value or something like that. It's calculating that, and then we want to use the information that it's the result of that information. So in this case, we want to use number 3. Well, what we can do is we can return the answer, or return the output to this. Okay, and we do that by typing return. Simple as that. And what we can now do is, because this is returning a number, we can actually what's the word? I'm just going to do it because I can't think of the word. We can say result is equal to this, because what we're actually now doing is we're saying, okay, we're calling our add function, we type in num1, num2, we're going up to this method, it's performing an addition, it's returning the result of this, so it's returning the sum of these two numbers down to here and storing it in result. So if we now print result, we can see that the result is indeed 24, which is the right answer, which is good. So what you can do now is you can see, well, you can use this same process to create a calculator. So pause the video now, and I'm going to pause as well because it will take me a few minutes to write all of this out. But yeah, pause the video and try to create the add, multiply, subtract, division, maybe a power or something like that. And yeah, I'm going to pause the video and come back to you. Cool. So hope you were able to get that, and if not, we're going to walk through it now. So what I've done is I've used the same add method as before, and pretty much used it as a kind of a template really, and the only thing I've changed is the symbols, multiply, plus, divide, minus, and so forth, which is perfectly okay for this this sort of thing. Then we've gone to power, and there's a few methods you could have used for this. You could either use this double asterisk method, which is doing essentially the same thing as what this is doing, which is the Python version, which is the inbuilt Python function, which uses a power. So it essentially goes that number 1 is the number, and number 2 is the power. So number 2 can be to the power of whatever. What else? Oh, and you could have also, I guess, done a for loop and use a range-based for loop to go through as many times number 2 is and times number 1 by itself that many times. So that's another way you could have done it. I've then done something a little different. I've created a method for a quadratic function. Now this is only for real roots, so it doesn't take into account complex numbers or anything like that. And in fact, I've made sure that if the operand is a minus number, then it doesn't do anything. It just returns -1. But this is an idea. So using the operators is absolutely fine for a method, but this is probably usually what you're going to get. You're going to have something with an input of values, and it performs a few different pieces of stuff, and then it returns a value. So in this case, it returns 2 roots. And here are just my printed results. So if we run this now, let's do 4 and 4. So this will be, in the quadratic, it will be the equivalent of 4x squared, 4x squared plus 4x minus 1, I think. Minus 1, I think, roundabouts. So these are the values we get. So that's the plus, minus, oh no, that's the multiply, and you get the idea. Now for the quadratic, I just want to make sure that I did actually get it right. So I've got Wolfram alpha open. So I've done 4x squared plus 4x minus 1, and we can see that the first root is -1.207, which is -1.207, and 0.207, 0.207, good stuff. So we can shut that down. And we can do this with any sort of number, so, go ahead, try it out. This is how I did it. I again used a printf statement, and I put in the result for root 1, a new line, and then a result for root 2. I think that's pretty much. Oh, the other thing is you'll have noticed that I only actually inputted 2 numbers, number 1 and number 2, whereas for a quadratic you need 3 numbers, ideally. And that's what I've done is I'm using the exact same number that we've got for number 1 and 2 here as A and B, and then for C I'm using a default number. So this means that if you don't provide enough numbers, enough arguments in your function, then you can set a default number. So, if in this case we're only using 2 numbers, so Python is going to say, okay, since you've only used 2, we're going to use this default one. If, however, we wanted to use the third number, so where's my quadrant? There we go. So let's say we want to do the exact same number. Let's say, but get rid of that. So let's say C is -1. So we get the same number. Run it. Number 1 is 4. Number 2 is 4. And there we go. We get the same number. The difference here only is that here we're providing 3 values, whereas before we were providing 2 values, but in our function we gave it a default value, which can be a really, really useful thing to do. So this has been our video on functions. We've created a calculator. Oh, the other thing as well is to use the Python power function, we need to import math. Which is the maths module for Python. So yeah, that's it for this video. We've looked at functions and passing arguments into functions. We also kind of, I hope, have a decent understanding of how to use functions, where to use them, and also, things like how to return a value from inside a function, which can be a really, really useful thing to do. So next video we're going to probably be talking about mutability, which is quite an interesting but quite a complex topic to get your head around, I think, at first showing. So anyway, yeah, I'm going to stop the video now and have another play with this, implement the quadratic, perhaps implement a quadratic with complex numbers as well. That's perfectly doable. And yeah, just generally have a play around. Is there anything else? I think that's about it. Yeah, so until next time, see you in a bit.